Alright, so this video is going to be about using proportional relationships, but specifically we're going to talk about the perimeter and area of similar figures. Okay, so here I have two similar figures. I have two triangles, and they're similar to each other. You're not going to be able to draw everything that I do, so just make a good picture, write down the key things, and this is more of a pay attention than a write everything down kind of lesson. But the first thing we want to do is find out how far it is from E to F, and then how far it is from B to C. And then we're going to divide those two numbers. So I've already got it set up here where I can just bring up those measurements. So the distance from D to E, so that's down here on the bottom, is 7.17, and the distance from A to B is 4.78. And the software will calculate those distances, so as I change, the distances change. And you notice that DF and AC are not changing because I'm not affecting those distances, so they stay the same. I can move that one and change it, but I won't be able to change all three at the same time unless I was able to move all the points, which we'll do in a little while, but for now, let's just stick with that. Now, to find the similarity ratio, that means I need to take this and divide it by this. So what I'm going to do is use a little tool on here, and it does exactly what I just said. It'll do this divided by this. So when I divide those two things, I get 1.5. And that may not seem overly exciting to you right now, but hopefully you recognize that 1.5 is equal to 3/2, right? That's 3 over 2. So we're going to stick with 3 over 2, and I want you to notice that when I change DE and AB, so that's, if I move E, these numbers are still being divided, right? It's still doing DE divided by AB. So even as I change it, it's still figuring and calculating that ratio, and it's still exactly 1.5. So that's kind of neat that it stays 3 over 2 no matter what I do. So then I'm going to figure out the other two, and hopefully you know that I should expect that they equal 1.5 if these triangles are similar. So there's that one, and I'm going to do this one divided by this one. Again, 1.5, 1.5, 1.5. Everybody's happy. Okay, so I'm going to move these out of the way just because I have some other stuff that's going to go up here. So we've got that 1.5. We know that's 3 over 2. 3 over 2. So our similarity ratio here is 3 over 2. Easy enough, right? Now we want to talk about the perimeter. So to find the perimeter of this triangle, normally I would have to add this. Whoops. It's unfortunate. To find the perimeter of this triangle, I would have to add this, plus this, plus this. Right? Well, lucky for me, this software does it. So I don't have to do anything. I just tell it I want to know the perimeter of that, and it tells me what the perimeter is. So now I have this perimeter and this perimeter. And what we're supposed to learn here today is how the similarity ratio applies to area and perimeter. So what do you think is going to happen if I calculate the ratio between the perimeter of DEF to the perimeter of ABC? And just see what do you think is going to happen. Do you think it's going to be the same 1.5? Do you think it's going to be more, less, some kind of combination of it? Okay, so it's going to be exactly 1.5. So the perimeter of DEF divided by the perimeter of ABC equals exactly 3 over 2, just like the similarity ratio already was. The interesting one is when we get into the area. So if I talk about the area of these two triangles, that means all the space, in between the segments and the points, all this space inside here. So if I want to look at those, I can measure those areas here. So the area of triangle DEF is 12.69 centimeters squared, and the area of triangle ABC is 5.64. And keep in mind, these are all linked together. So as I change this triangle, the area calculates, the perimeter calculates, and you'll notice that perimeter ratio never changed either, just like the side length ratios. So the question here is, what do you think is going to happen when I divide these two numbers? I'm going to compare them by division, so I'm using a ratio. So I'm going to use my calculator again. And let's see if you know what's going to happen, or if you think you know what's going to happen. So I'm going to do this, divided by, and then when I do the next one, triangle ABC, let me move this out of the way, maybe you can see the numbers. What do you think is going to happen? Do you think that it's still going to be 3 over 2? Do you think it's going to be more, less? Just think about it. So when I actually do it, I come up with, and I know it's kind of hard for you to see because it's on the writing, I come up with 2.25. And at first glance, you might see that and think, well, that isn't really doing much for me, Mr. Lewis. Well, it is doing a lot for you, actually. And what you may or may not see is that 15 times 15 equals 225. So what that means is 1.5 times 1.5 is 2.25. So effectively, what happened here is our 1.5 ratio got squared. And that's convenient for us because area is always squared. So that's an easy way to remember that the area of a figure, the similarity ratio between the areas of two figures, is always going to be the similarity ratio of the side lengths, but squared. So what does that mean? Well, what is 3 over 2 squared? Well, 3 squared is 9, and 2 squared is 4. So I can take this and I can take these points and I can make this thing just move all over the place. And you'll notice that while everything's moving, this divided by this is still 3 over 2. This divided by this, still 3 over 2. This over this, still 3 over 2. I do the perimeters, still 3 over 2, nothing's changing. And when I do the areas, 9 over 4. So it's just the similarity ratio that we found, but it's squared because area is squared. I don't know why my little circle moved. Oh well. Small problem to have, right? So anyways, I got these triangles moving all over the place. So I'm going to stop them. Alright, so the big idea that you're supposed to take away from all this, right? The whole point of doing all of this is for you to learn, recognize, and then memorize this theorem. So if the similarity ratio between two similar figures is A over B, then the ratio of their perimeters is also A over B, and the ratio of their areas is A squared over B squared, or A over B squared. So this is the big idea. This is called the proportional perimeters and areas theorem. Okay, so this is not going to be a reason in a proof. Okay, this is just something you need to know. You're going to get problems about side links, and they're going to ask you questions about the similarity ratio between the areas. You just need to know that you find the side length ratio, the perimeter is the same, the area is whatever it was squared. So that's it.